So in this tutorial, I'm not actually going to show you how to model anything. That's on you, and I suck at modeling stuff. So for the purposes of this tutorial, we're just going to be porting this Lego car. So the first thing you really need to do is just convert everything to diesel standards to make your life easier. So stuff like that includes using the prefixes such as G underscore to represent graphics objects, CO underscore to represent culling objects, or C underscore to represent collision objects, etc., etc. I might stick a full list of them on the screen if I can be bothered, but otherwise we can just go ahead and get started actually naming this stuff. For the purposes of this tutorial, we will also want to be splitting up any animated parts that we want to have animated, such as the wheels here, and potentially the doors. Okay, so now that's all the wheels split off, we're then going to want to set their origin points to something a little bit more useful for when it comes to actually animating them. So usually that'll be where you want the wheels to actually turn and rotate from. So using the middle inside vertex is typically good enough. So normally I just move the cursor to that point and then use Shift S to move it there, and then Control Alt Shift C, if I press the right buttons, to set the origin there. And rinse and repeat for the rest of these. Okay, so that's all the wheels done. If we give them a rotate using R and then any of the axis buttons, you can see that they're not too shabby. If I don't accidentally press Z and set it to wireframe mode, there we go. Obviously there's going to be clipping because it's a Lego car, can't do much about that, and that's not the point of this. If it looks crap, then it's going to look crap. But otherwise, it looks pretty good. So we want to obviously give them decent names as well. And as far as animating concerns, we don't really need to split it up anymore. I guess we could give the doors a go. If I can actually have that set up. So I'm going to go ahead and split the doors off as well. I'm not going to because they're too joined up, and I can't be bothered to actually generate any new mesh stuff. So next up is we'll want to give the materials actually standard diesel names, because text underscore 60047 underscore police car is a terrible name for a material and is very unclear. So we can just click that and give it a rename. The standard prefixes for diesel materials, as far as overkill is concerned, seems to be MTR or mat underscore. So MTR underscore like that, or MAT underscore. I prefer MTR because material, it doesn't particularly matter. It's not going to complain or anything if you name it something completely different. So, and that should update along to all the materials in the mesh, which is nice. And you want to do the same thing for all of them. Okay, so as far as porting a static mesh concerns, this is virtually all we need to do. The last thing we need to do is line it up with the axes. So a very nice thing is that diesel and Blender's coordinate systems are identical. So Y is forward, Z is up, X is left and right, etc., etc., which is great. The only problem comes is the model tools don't correct for that when it's to the standards of the formats they export in. So when importing existing models, they will import sideways, despite the fact that the engine's coordinate system should be identical to Blender's. Fortunately for custom stuff, the GLTF format, which we will be using because it is amazing and great, and Kytheria has done an amazing job at developing that, we can just go ahead and have it conform to the engine stuff, and on export, have it deal with it. So all we need to do really is, because Y is forward that direction, we just need to rotate everything around the origin point and it'll be good. Last thing we need to do is set up the hierarchy correctly. So in order to have it conform to other weird standards, is we will need an empty, if I can find one. It doesn't really matter what type, the empties are all the same. And just give it the name of a root point. I prefer root_point, it gets to the point, and it's basic enough. And then we just parent everything to it. I prefer making my own new root point because the model I typically use to import custom objects on is actually an empty MP5 model, and the MP5 root point is kind of strange to have, and it doesn't make the model that much bigger to add my own new root point. And the other thing I'm actually going to add is empties to go with the wheels, because when it comes to animating, it will be far easier for me to animate the individual graphics objects spinning like this for when the car's moving forward, etc., and have empties that I can then rotate to handle steering, instead of having to try and compensate between two different axes that might be spinning at different rates. So for that, I will just need that on the front wheels if I'm making the steering with the front wheels. So we can go ahead and do that as well. Just adding 2 more empties. Give them fairly relevant names. The prefix for generic stuff to help with animation tends to be anim_something. Wheel name, it doesn't really matter. And then we'll want to move them to the wheels so that the transformations don't change. There we go, and we can just go ahead and parent them to the empties, and then parent the empties to the root point, like so. And there we go, we have our hierarchy set up. For most people, this should work 99% of the time and be easy. But yeah, as far as setting up your model for importing goes, this is it. Not much else you need to do. Obviously, if your model hasn't got a UV map, you'll want to actually set it up to be mapped properly. But other than that, everything is good to go. So I'm going to go ahead and save this, and because I don't want to lose it, because it will be a pain in the ass to create again. So there we go. So now we've got our model set up, we'll want to export it as GLTF. If you're using Blender 2.8, it will already have GLTF exporting and importing. If not, if you're using 2.79 or below, I will link the GLTF plugin in the description and you can go and download it. As far as I can tell, the official 2.8 Blender one is identical to the plugin. I have not found any differences, so as far as this is concerned, it should be the same. And because we made our model to conform with the standard coordinate system, we will want to untick the +y up option here, which will then ignore the GLTF conventions, meaning this gets put into the GLTF wrong, quote unquote, but the model tool sees it as right because weirdness. I'm not going to explain it too deeply, but it means that the axes stay the same when porting across, and this makes animating a lot easier later on. Oh, I forgot to cover one thing. Diesel doesn't like hard edges when it comes to, let me just go into edit mode, shading for normals. They just look crap. So what you will find in a lot of models that you've imported from the game is they will have split edges, which I think this model actually makes use of. So whatever the engine of this original game used probably suffered the same syndrome, which is here you go, you'll see it, is where they've actually split off the faces so that they are completely separate and they actually look like hard edges correctly when imported. What I like to do for completely custom models is, instead of edge splitting and applying that permanently, what you can do is you can get the edge split modifier, set it to split sharp edges, so edges that you apply as being flat or sharp, etc. I've moved out of edit mode, apologies. Here we go, sharp means they will be edge split, but not on the actual model, so that when it comes to animating things or editing the model later on, it's not an absolute pain in the ass. But what the nice thing that the GLTF exporting offers is you can then apply the modifiers on export, so that when they eventually get re-imported into Diesel, they don't look like garbage. Yeah, so we can just go ahead, export it as either of these. The model tool supports either, it doesn't really matter. And just go ahead and export, let it do its thing, and there we go, it's done. So we're going to go ahead and move across to the model tool. No, we're not going to move across to the model tool, sorry. We're going to go ahead and move across to the to our custom heist. We're going to set up a custom heist to test stuff in. So we're going to cut across to Payday 2 quickly and rapidly set up a custom heist, and I will come back to you once it's set up. Okay, so we have created our test project here, and we are inside its assets folder, inside the map folder, project respective folder, and we're going to want to create our file structure for our custom assets. Typically, most Payday content is structured as units / some kind of identifying collective folder. The standard Payday 2 DLC uses pd2 underscore DLC underscore whatever the DLC's ID. I tend to go for pd2 underscore mod underscore something to identify that mod, so I'm just going to go test. And then we have our folder to specifically identify what is like a group effectively. So characters tend to be stored in characters, or props, as in the case we're going to be doing here, will be stored in props, etc. Pickups and pickups, blah blah blah. So we'll go into props, and this is where there's a little bit of contention. It's not the biggest thing in the world. I like to put things in folders because it makes organizing stuff a little bit easier, but it makes the file path a little bit stranger. Some people don't. I'm going to be sticking with the folder method, and to keep within standard Payday standards, we're going to go for, I think it was anim underscore and then an identifying name for that prop. I'm actually going to double check that 2 seconds. And I was correct, I'm not going insane. So we're just going to carry on creating the necessary files for our new unit. So the first thing we're going to need is, these are all going to follow the same naming standard as well as the original one. We're going to need a .unit file, a .object file, a .material underscore config file, like so, and the last one we're going to need is, if I can remember correctly and I'm not going insane, is the model, which we will export later on. Doesn't really particularly matter. So these are the three main files that we'll need in a second. We'll set them up after we've exported the model. But for now, I'm going to go ahead and set up the add.xml and the, just the add.xml folders for the file. So typically a default one is located inside the main level folder. We'll go ahead and open that up and bring it over on screen. Here we go, Sublime, very exciting, very fun. And it will already be default pointing to our assets folder, which is this folder here. So we'll want to go ahead and open that like that. And I'm going to quickly double check an existing asset folder, add.xml, because I don't remember the format for this. And I'm going to steal it. So the first XML you want to add is this add path equals blah 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 blah, and then the type. You will almost always put unit here, and essentially this stuff here is kind of extra metadata-esque stuff, so that BeardLib can read it and know to add this unit to the heists unit spawning menu for when you want to place it in the heist. And then the next kind of few bits are fairly basic. You will want to add new XML entries with their keys being the file type and then a path to that file. There we go. So yeah, there you go. Go ahead and get a nice look at that. It should be fairly self-explanatory. It's just standard XML syntax. And so now this is here, we can go ahead and export our model. So if we so like I was mentioning before, there is a specific source model that I prefer using, and it is actually, if I can get Diesel Bundle Viewer up, here we go. We open up Diesel Bundler Viewer, and open up Payday 2 assets. Give it a second. There we go. If we go ahead, go to Units, Payday 2, Weapons, and then, where is it? It is, I can't find it. Apologies. There it is, weapon upgrade dummy, and we can steal the model for that, because as far as I can tell, this is the most bare bones model in the game. If there is another one, I would love to know, but as far as I'm aware, this is the smallest, most bare bones model we can use as a base. So I like to just extract this somewhere. Oops, sorry, I've accidentally extracted the object. I like to extract the model and just have it lying around as the base, because trying to redo content over a model you've just made tends to be a bit wonky. So now we've actually got our base model, we've got our GLTF that we're going to import. We can go ahead and set it up, give it a go. So we want to go ahead and actually open the user model tool. The one we'll be using, I will link in the description as well, because it is not because there are sort of two different model tools that get used, and it can be a little bit confusing, but the one for this I will link. Okay, so we've got our model tool here. We want to select our base model, which will be the one in this folder here. We want to find our new model, which would have been in, apologies, I've lost the folder already. No, not that one. There it is. In this model here, and want to import objects not in the base file, and we'll just want to save it back to this folder, and we'll just use the same naming standard as the other files, and go ahead and click convert, and it should just do it all. So you'll notice our new model has a much larger file size than the original model because it's actually got model content in there. And if we actually go ahead and select the model inside the object viewer, you should see we have our new root point here with our body, the studs, all our wheels in there, as well as our anim points with the front wheels inside them. And the beautiful thing with GLTF is this basically works perfectly for anything static. I have had no problems. I have been able to import thousands of objects and it's just worked. It is amazing. Obviously geometry as well. So now we've got our model, we can effectively go ahead, close the model tool. I'm going to keep Blender open on the side because we will need to remember the names of our materials once we set up our material config. But for now, we're just going to go ahead and set up our object and our unit. So usually I can't remember the exact way these are set up, so I will just be stealing objects and unit data from other things and editing them to fit this new use case. And most people do this because the syntax for them is kind of generic and difficult to remember. And I won't blame anybody if they also do the same thing. I'm not going to steal that one. So we'll go to our object, steal it here, and I will cut this down to bare essentials to what we want to see for now. So we've got our material up here. We just want to change this path to fit our material config. So because it's the same as this file's path, we just need to copy this file's path again. There we go. Our orientation object is the root point. So in this case, I have used the same root point in other files. So root_point. Obviously, if you use a different root point name, change it to fit the case. But this essentially defines which object is the origin, if that makes sense. We don't have a sequence manager. We will once we get to animating it, but for now we will not. And the same for an animation_def. And we just want to set up our graphics objects. So if we go back to Blender, just to remember what those were called, because I do not remember, you will see we had g_body. And you want enable to true onto there. Ooh. g_studs. g_wheel_back. Ooh, back left. Back right. Blah blah blah. Just do the same thing for all your graphics objects that you actually want to show up, and you can space them out if you like them being a little bit more organized and you don't want to mess. g_windows, and we'll do the last two wheels. Don't forget about the ones inside the anim objects. Ooh. There we go. So we've got all our graphics objects here, and then we'll want to set up our. I've accidentally put these in the wrong. This is the unit. Sorry, we'll put these in the object. There we go. And then for our unit, I'm going to steal them from this file as well. Paste it in there. For vehicle, the type doesn't particularly matter. It's more of an identifier, and the slot will change based on what you're using it for. My best advice for figuring out what slot you want is to just find the closest equivalent of a vanilla asset or an asset that somebody else has already done and use the same slot, because slots are used to define the things such as differentiating things from the environment, etc, etc. But for map props, as far as I can tell, slot 1 seems to be the one to use, but I have seen slots such as 39 and others used around the place. So for the first one here, object file, just should be fairly obvious, but just pointing that to the .object file that we've just defined before. So because again it's the same path as the unit file, we can just type that in again. We won't have an anim state machine just yet. We'll come back to that, and the same for these dependencies here. You will want this network sync though. For map props, as far as I can tell, this is necessary. This sound stuff can also go, and this extension head is not necessary if you are not animating. So for a standard static object, this is fine. It is the bare necessity, and you don't even need damage either, you just need unit data. That's all you need. It's fairly small, nice, easy, plain. So now we've got our unit and our object set up. The last thing to do is our material config. Now this can be a bit annoying because, again, weird formats that you have to remember, so I'm just going to steal material stuff from here. Here we go. So we have our version here. I don't think anyone has actually figured out what these versions exactly represent. I keep them in for the sake of keeping them in. The name here, this will be the name that the materials are actually called in Blender. And the render template, you will want to either look at examples from existing vanilla or modded assets to find out which one of these is available, or if you are particularly more technically inclined, if you check the extract, I should have an extract ready, if I remember where I stored them. They will be under Payday 2 shaders and then base.render template database, sorry. And we set the syntax highlighting to XML. We can see this is all of the render templates available to you. This is a pain in the ass to search, so if you can find existing references for what you want to do, it's usually a lot easier because you will also have reference textures to look at. But if you're in a pinch and you need to look at stuff that Overkill hasn't necessarily used in-game, this is the next best thing, because they also have UI names and stuff which describe what they're supposed to do, and it will also give you the number of the UV map that texture prioritizes. If it can't find this UV map, then it will just default to the base standard UV 1 or 0. I can't remember. UV1, sorry. But yeah, this is more complicated stuff. I'm not going to go too deep into specific render templates. I'm just going to set up render templates enough so that they work. So for our first material, we'll just need to set up, to find out what materials we have mtr underscore police car, mtr underscore studs, and mtr underscore windows. So I will just set that up in the order that I've created them. And we will give paths to two textures that I haven't created yet. If I don't set up the paths wrong. Here we go. Anim underscore police car. There we go. And sorry, no, we want to give that a path to. We'll just call the texture police underscore car because we're going to only have a diffuse, sorry, and I'm not going to be faffing around with any opacity textures or stuff like that. So the next one will be mtr underscore studs. We'll just give that studs, and then mtr underscore windows here, and we'll just give that windows there. Okay, so that's our material config setup, and the very last thing we'll need to do before we can give this a go in game is to set up our textures. So I'm going to preemptively add these to our add.xml. So we'll set up our texture paths, and because their base path is the same as everything else, we can just go ahead and copy and paste. So we had police car, studs, and what was the last one? Windows. There we go. And so, if I go to our original assets here, we have them here. We have our police car texture, the stud texture, and the generic transparent stuff. What we can do is we will want to just go ahead and go to our police car folder, and we'll go ahead, open these up in I prefer Paint.net because it means I can export this straight into DDS, and I don't have to faff around with any plugins, but you can get plugins for GIMP, Photoshop, all sorts of text rendering applications. And one thing to note is the really gross thing is that Payday 2 and other Diesel games use the alpha channel as the specular map. So I'm going to be super lazy and just make it really transparent, just to save this, just to get it out of there. So we'll just go ahead and save them here. So police_car.dds, and then for most in-game uses, you will want to be saving it as dxt5, or as Paint.net calls it, BC3 linear dxt5. If you have no transparency, I recommend dxt1, because that only stores a binary, either it's transparent or it's not. Typically you won't be using dxt3, it's effectively dxt5 but with less transparency data. And so because we want to retain our transparency so that the specular doesn't become shiny as hell, we will save it as dxt5. And we'll just do the same thing for all these other textures as well. Okay, so that's all our textures here in DDS format. And the final thing that we'll want to do is rename them all to doc texture. But one of the things I like doing is, since the skin update, you don't need to rename them to doc texture. Lots of people still do it because of standard, but I've actually started preferring not doing it, because trying to re-edit doc textures if you've already edited them and resave them is a pain in the ass. What you can do is just go to your add.xml, and instead of putting texture, just put DDS. That works perfectly fine. You can also technically use formats such as PNG and TGA, but they're not exactly designed to be loaded into memory very quickly. So I will always recommend using DDS over the top, despite the fact that you will experience some form of lossy compression when saving as them. So as far as everything goes, we should be perfectly fine to go in game and give it a shot. Okay, so we're finally in the editor. We can go ahead and we should be perfectly fine. There we go. If we go to spawn, and provided that all your unit file, object and material config files are set up correctly and your model is fine and it all loads, you should be able to search for your asset, place it in, and there we go. This is rotated incorrectly and I'm unsure why. Well, that's mildly embarrassing. So we'll go ahead and have to take a look at that. But there is a few noticeable other problems. You'll notice that I have now unselected it and I can't click on it anymore. Because, one, the police car has no collision. And there is also another quality of life feature that we might as well add to the model if we're going back to edit it anyway, which is culling. And culling is essentially just adding a box, a generic box, to say this is the model. If you see this box, render the model. And this is very easy to add. It just takes a little bit of extra work to add a box to it. Again, not a lot of work. So we'll cut back to Blender and we'll have to fix these issues. Okay, so we're back in Blender. I want to diagnose the rotation issue. I don't know why that didn't work. I probably exported it wrong. So I'm just going to go ahead and apply all the rotations again, just to make sure they are all aligned towards the Y, Z, X, Y forward coordinate system. So I'll just double check what my export settings were. So there you go. I forgot to untick plus Y up when exporting it. So just exporting that again will confirm that it's fine. And for collision, this is a fairly simple thing. I'll just go ahead and quickly set up a little collision. It doesn't have to be complicated. We'll just give it something basic. Okay, so here's our very, very garbage basic collision model. For this, I'm not going to make it too fancy. Sometimes if you're ripping models from other games, they'll come with collision models and they'll work fine. But for this very basic one works well enough. So we'll go ahead and save that again. And we want to give this a fairly nice standard name, so I'm just going to go C_body because it's the collision of the body. And once again, parent that to the root point, and ideally have its origin fairly nice and standardized in the middle, because it gets a bit messy when your origins are all over the place. And like the other thing I will do, like I said before, is we'll add a culling box. This will be even easier to do than a collision. Just get another box, center it again, and just edit it so that the box surrounds the rough area of the object, of the model. Usually you want to give it a little bit of leeway so that it doesn't cull too early and you get the player catching it disappearing, which is ideally not what you want to happen. So just surround the entire thing with the culling box like that, and we'll have our origin and center again there just to make our lives easier. We'll go ahead and save that. We'll give it a nice name. We'll call just co_cull or something, culling object for culling. I don't know. That's what I like to call mine. You can call yours whatever. So we'll go ahead and save that, and we'll go ahead and export that again. Remembering to untick +Y up if you've conformed to this coordinate system. If you have gone ahead and conformed to it facing Z with Y being up to some extent, then you will want to export it with that option ticked. But otherwise, we can go ahead and export it again with our nice hierarchy, and we can go ahead and go back into the model tool. Okay, so now we're back in the model tool. We will just repeat the same process as before. Select our base one. We'll select the one. Because we've already made it, we can just select this and replace it. And we'll get our object, which was, I can't remember where this was stored. Sorry. We'll go and find it. I can't find it. There it is. We'll get our GLBeast or GLTF, import objects not in base file, and we'll just go ahead and convert it again. So we should notice if we go back to the car, it will be slightly bigger with the introduction of our collision and our culling. So next important bit is we need to go ahead and add that culling and collision into our object file. So once again, I'm going to refer to existing assets just to make my life easier. So we will need to use some bodies XML for our collision. So here we go, bodies, blah blah blah, and then the body. We'll give it a name, body_vehicle. Works again. We want it to be enabled. And if you are likely to be animating this, you will want to use the animated template. But if not, I am pretty sure you can exclude this and you will be fine. We want an object to attach our collision to. For most cases, unless you're specifically animating objects separately from each other, you will want to be attached to the root point. But for example, say you've got parts that move completely separately, you'll want to attach it to the part that's moving. And we'll get the name of the collision. So C_body. And because we modeled the collision ourselves and it is not a basic cube, because it actually has some complexity and we've modeled it ourselves, we need to use mesh_mop. But if you look at vanilla assets for reference, you will find many other collision types such as capsules, cubes, etc. And if your collision is a purely basic cube or capsule, blah blah blah, you can use those collision types. And then for our culling, we will, sorry, I haven't used culling on this object. If we find an object I have used culling on, I haven't got a reference form. Give me 2 seconds. here we go. I've pulled in here we go. I've pulled in some reference data. So for culling, you will want to make a graphics group, or graphic group, sorry. Give it a name. Doesn't particularly matter unless you're going to be later interacting with that graphic group. So I just call it something generic. You want it to be enabled, and then you can give a culling object to that graphic group. So for this case, because I've already called it co_cull, we can keep it the same. And graphics group is also a nice way to just sort of group things and split them up, especially if you're going to be interacting with them later on, and potentially with sequences or with Lua. But for now, this should be all we need, and we can go in game and give it a spin. Okay, so we're back in the editor, and because I saved it, the car is here. As you can see, if we go ahead and delete that and replace it, you'll notice the car is now the right direction. Amazing. So double check your export options, or you're going to be in annoying pain. You notice it actually looks pretty good. I'm surprised that it doesn't look more crap. You'll notice we can actually click on it now. Yay! And you'll also notice the bounds actually conform to the culling box, because we now have the culling box around it, so that when the player's not looking at it, it does cull correctly. Obviously we can't test that, because the whole point is that you see it when you look at it. But yeah, as far as static models you go, this is it. We've got it in game and it works. We can go ahead and cut it in game, see how it looks when we're walking around. Okay, so here we are in game. You can see it. We can rub our faces against it. We can hit it. We can shoot it. It blocks our shots. Yep. We can stand on it. The heists AI can stand on it. And yeah. The only thing that you'll notice is not functioning is if we shoot it, bullet decals or other decals will not show up, because once again we need a special object for that. Or sometimes you need many objects if you want to get the effects that you're looking for. So we're going to go ahead, cut back into Blender, and for hopefully final time, we'll be good to go. Okay, so we're back here in Blender, and the final object we will need to add for bullet decals and the like is a damage object, as I call them. These are usually prefixed with DM underscore, and they're effectively like a collision object, but for where the bullet decals are supposed to show up. I'm just going to be lazy and copy the collision object, because I am not particularly willing to go through the effort of making a proper damage model. So if we can go ahead and actually show that, copy and paste it, if it's going to do it. There we go. Just rename that DM underscore body. Typically you'll want separate damage objects for separate materials, such as windows or wood, other materials, so that you can actually set them to use correct decals. But for the purposes of this, I'm just going to have one damage object for the entire model. So we can go ahead, parent that once again. Go back into the model tool. I've still got it set up, so we could just click convert. Oh, apologies, I haven't exported it. Remember to export it. Once again, correct settings. Export it. Go to our model tool. Convert. We've done that. And we can go into our object, and I will need to find a reference one, because I have as of yet to make a personal asset that actually makes use of this. Units. I will check one of the props in Payday 2. Here we go. Apologies, they are called decal message, not damage objects. So I'm going to use, here we go, there we are. So you want a decal surfaces XML object, and then inside a decal mesh object for each individual decal mesh that you will have in the model. In this case the name was DM underscore body. You'll once again want it to be enabled, and we'll insert a material. I'm just going to leave it as is because I don't have a comprehensive list of the materials available. Once again, best thing I can recommend is take a look at other examples of similar things that you know have the right materials that you're looking for in existing assets, etc., etc. Yeah, it's easy as, and we'll once again go in game. We'll have a look. Okay, so we're in game. We can give this a test, and there we go. You'll notice that the bullet decals are there properly. They're not perfectly aligned because I was lazy and just used the collision object, but if you design a fairly decent decal mesh, it should look pretty alright. Yeah, as you can see, they are inside and a bit wonky, but for the purpose of this, it works pretty well. So, that does it for part 1. So I should have covered all the basics of static object, getting the model in, splitting it up, getting it to mostly work with diesel, basic material stuff, damage meshes, culling objects, collision, etc., etc. In the second part, I will be demonstrating how we can animate this and how to deal with the nonsense that the game has to have so that the car and other animated vehicle props sync correctly to other clients. But as far as static objects go, this is it. Here we go. Thank you for watching, I guess. Bye. Bye. Fuck off. I'm done. This took me an hour to record. I'm fucking done. A dog barked halfway through. I'm gonna fucking die.